questions on the homework before we get started? Got it finished? Sweet. We are, but if there's questions on the homework, we'll cover them first. So 1.1 is, we can do part 2 too. I've got one here. P2. $99. Now there's different ways we can do this. One of them that's a little bit nicer is problem number 99. Because the way we did this in class is that we rewrote our 3/2 exponent as the square root of x minus 5 cubed. So we rewrote that back out. The other way we can do it is put it to the powers reciprocal. Because powers of powers multiply. So on the left-hand side, we have x minus 5 to the 3/2 to the 2/3. Well, the 3/2 and 2/3 would multiply. 3/2 times 2/3 is 1. So, bless you, the left side would become x minus 5. Now on the right-hand side, we have 8 to the 2/3. Eight to the, bless you, 2/3 is 4. Now we have this here. Now, if the the denominator of what we're putting both sides to is even, so here it's odd because the 3 2/3. What we're saying with the 2/3 is that we're taking 8. The top number is squaring it. It's what the power to it is. The denominator is the root. So since it's 3, we're looking for the cubed root. If we take an even root, we need the plus or minus. If we take an odd root, we don't. So if it had been an even root, we add the plus or minus. Since it's an odd root, it's just 4. Now we just need to solve. And here we would add 5 to both sides, telling us x is equal to 9. Any questions on any of the other assignments? 98. Yeah. So 98, we can solve it with the radicals on the same side. It's going to be easier to move one of these radicals to the other side. So we'll add this radical to both sides. So we have 2 square root of x plus 1 is equal to 1 plus the square root of 2x plus 3. Now we could move the 2 to the other side. We'll leave it where it's at. But once we even the radicals out, we're going to put both sides to the nth power. Now, since there's square roots, we're going to square. Now, the left-hand side, the 2 and the radical are being multiplied. So if we multiply it by itself, it's just saying that we have 2 square root of x plus 1 times 2 square root of x plus 1. 2 times 2 is 4. Our square root of x plus 1 times square root of x plus 1 is just that square root squared. And a square root and a square will cancel out, leaving us with this here. Now the other side, we do have this full thing here. Now since 1 and our radical are being added, we are going to have to distribute this out. Okay? For simplicity's sake, I am going to end up kind of skipping some steps. 1 times 1 is 1. 1 times our square root would just give us this square root back. The square root times 1 would also give us it, so we actually have 2 square root of 2x plus 3. And our square root of 2x plus 3 times the square root of 2x plus 3 is our square root squared, which just leaves us with 2x plus 3. So I simplified that a few steps down, so we're not having to rewrite the radical out twice, adding them together, or having our radicals squared. Left-hand side, we can distribute the 4. 4 times x is 4x. 4 times 1 is 4. The right-hand side, 2x doesn't have any like terms. 1 and 3 is 4. Now, since we still have a radical, we need to get it by itself. So we can minus 2x from both sides. We can minus 4 from both sides. On the right-hand side, 4 minus 4 is 0. 2x minus 2x is 0. Leaving us with 2 square root of 2x plus 3. On the left-hand side, 4 minus 4 is 0. 4x minus 2x is 2x. So now we have to get rid of that last radical. Now, as we saw already, we can leave it 2 square root of 2x plus 3, and we can square both sides. That works just fine. The other side, 2x, is it divisible by 2? It's 2x divisible by 2. Yeah. So here, if I wanted to, we can divide both sides by 2, telling us x is equal to the square root of 2x plus 3. Now, if we look back up here, well, why don't we do that over here? Is 1 and our square root of 2x plus 3, are both of those divisible by 2? Well, no, one's not, so it's better to just leave it. Here, it's divisible by 2 on both sides. We can just get rid of that extra factor of 2. Now, as we did already, we're going to, again, square both sides. The left-hand side, x squared as well, just x squared. The right-hand side, square root and square, simplify. Now at this point here, we need to get this equal to 0. Telling us that x squared minus 2x minus 3 is equal to Thank you. Now at this point we can graph this and get our solution, especially if we have access to a graphing calculator. X squared minus 2x minus 3. Second graph, negative 1 and 3. And we can check it, negative 1 and 3. So to check, we would just plug it back into the top. So it'd be 2 square root of negative 1 plus 1 minus 2, or square root of 2 times negative 1 plus 3 is equal to 1. Our first radical would have negative 1 plus 1 is 0, minus 2 times negative 1 is negative 2 plus 3. Well, that whole thing is 0. 2 plus 3, negative 2 plus 3 is 1, which would be negative 1 is equal to 1. Okay. Negative 1 does not work. 3, 2 square root of 3 plus 1 minus square root of 2 times 3 plus 3. The first one would be 2 square root of 4 minus 2 times 3 is 6 plus 3. Well, the square root of 4 is 2. 3 plus 6 is 9. 3 times 2 is 4. Square root of 9 is 3. And 4 minus 3 does indeed equal 1. So it's just 3. You're welcome. So I graphed both equations, yes? So again, when we graph two equations and we're wanting to see where they cross, whether they're the same, we're looking for what value of x makes the y values be the same, which is 3, because when x is 3, both equations y value is or if we got the equation equals 0, we would minus 1 over. Now we're trying to see where it crosses the x-axis. And it crosses the x-axis at. Either way works. Questions on anything we've done so far? If you have any more homework questions, we can cover this. Yeah, email me or we can cover more of them tomorrow. Now, the unit circle. The two historical perspectives of trigonometry incorporate different methods for introducing trigonometric functions. One is the unit circle, is based on the unit circle. Consider the unit circle given by x squared plus y squared equals 1. So, all points on this circle are distance 1 away from the center, the origin. As the real number line warps around the unit circle, each number t corresponds to a point x, y on the circle. For example, the real number 0 corresponds to the point 1, 0. Moreover, because the unit circle has a circumference of 2 pi, the real number 2 pi also corresponds to the point 1, 0. From the preceding discussion, it follows that the corresponding x and y are two functions of the real variable t. So you can use this to find all 6 of our trigonometric functions: sine, cosecant, cosine, secant, tangent, and cotangent. Yep. So, other sheet, we'll get to the unit circle here in a second. Yep.
Oh, I wasn't looking for it.
Yeah. The 6 functions are abbreviated SIN, CSC, COS, SEC, TAN, COT. Now, these are corresponding sine and cosecants. SIN, CSC are flips of each other. So sine is equal to 1 over cosecant. Cosine is 1 over secant. Tangent's 1 over cotangent, and vice versa. We have our unit circle. Now, this here is 0 degrees. Okay? You ready for the radian amount for that? What would 0 degrees be in radians? 0 degrees, 0 radians. Now, all the way around would be 360 degrees, or 2 pi. Now the first one here, oh, wow, 9. Go away. Okay. Now, going around the circle, our first one is going to be 30 degrees, 45 degrees, 60 degrees, and straight up is 90. From here we have 120, 135, 150, and then 180. Then we have 210, 225, 245, not 245, 240, and then 270, 300, 315, and 330. $240, sorry. No, it is 240. I just was writing the wrong number. Okay. Well, let's get the radians. 5 over 6. 5 over 4. 5 over 3. 5 over 2. 2 pi over 3. I keep using the bar that they gave us as a division bar. 3 pi over 4. 5 pi over 6. Pi. 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. And 11 pi over 6. And then we get all the way back around with 2 pi. Questions on this so far? All right, there's one last thing we're going to fill in before I go to the next slide. 1, 0. 0, 1. Negative 1, 0. 0. Negative 1. So, now the unit circle is actually very helpful and very nice. So, this is the first quadrant. I need to go in and just have this filled in already. 3, 4, 5 or 6. 1. Okay, we're going to look at quadrant 1 first. Now, the interesting thing or the nice thing with quadrant 1 is that sine, cosine, and tangent are all positive. We can say there are no negatives for sine, cosine, or tangent. So none of the trigonometric functions in this are negative. Also, as a side note, be good to write. You don't have to write it up here in the dead center, but I would write it somewhere. All the points we're about to fill in, the sines value and cosines value, are going to line up this here. The x value is cosine, the y value is sine. So sine of 90 degrees, or sine of pi over 2, sine as the y value would be 1. Cosine of 90, cosine of pi over 2 would be 0. And it gives us this here. If we want to, we could take the calculator. Sine of 90 is 1. Cosine of 90 is 0. Exactly what it told us. We don't even have to type it in. The sheet will tell us. Now we also said that sine of pi over 2 is what? According to the sheet, what would it be? So sine is the y at pi over 2 straight up, so it should be what? 1, yes?
Oh, 1, 0.
So 1, 0, sine of pi over 2, so sine should be 1, yes? And it tells us that it is not 1. Now look at the calculator up here. It's right next to where I'm recording, the record button. What does it say? 3 letters. DEG stands for degree. So it's not seeing, so the calculator, when I put in sine of pi over 2, it's not seeing pi over 2 as a radian amount. It, for some reason, thinks you're saying pi over 2 degrees. So it's converting it to a degree measure. We don't need it in degrees. We would need it in radians. So mode. If you notice up at the top, the next one is RAD. We'll select it, second quit. Let's try this again. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So we see the distinction there. So if I try to do sine of 90, I'm not getting 1. Cosine of 90 is not 0 anymore. They give us completely different values. Kind of makes sense? Those two memes that I've had on the wall for a while, that are you still awake or not, or are you sleeping? This is what it's talking about. The calculator was set in radians, not degrees. But the calculator was set in degrees, not radians, because it will give you a completely different answer depending on if you're trying to plug radians or degrees in. If you're plugging degrees in, you need it in degrees. If you're plugging radians in, you need it in radians. It's going to differ for what it needs. But we have this here. So the other ones here, 30, 45, 60, sine of 30, sine of 45, sine of 60. 30. So I'll have square root of 3 over 2 and 1/2. 45, pi over 4 is square root of 2 over 2, square root of 2 over 2. And lastly, we have 1/2 and square root 3 over 2. I'm going to try to write that again. Now, the reason we get these numbers is because of special right triangles. Questions on any of this so far? So this here is helpful in that if I'm looking for sine, cosine, tangent, or sine, cosine of 30, 45, 60, it's right here. That's the nice thing about the unit circle, because cosine is 45, x value of that ordered pair, so it's square root 2 over 2. Sine of 60, we can look here and say that it's square root 3 over 2. This will do all the calculations. We don't have to always plug it in. This will calculate it for us. Don't have to check the mode because it's listed right there. We have them. Does that make sense? All right. Now the next one on this list is 2 pi over 3 and 120. Then we have 3 pi over 4, 135. And 5 pi over 6 and 150. They look oddly similar, yes? Now, positive, negative. Sine is positive in the second quadrant, but cosine and tangent are negative. Sine is positive in quadrant 2, cosine and tangent are negative. Okay? Now, each of the points, we're now in the negative x-axis, positive y. That's quadrant 2, negative x, positive y. So the x values are all negative, and the y values are all positive. Now, something we'll get to eventually, or in this chapter, is something called a reference angle. Now, with reference angles in this here, we set a straight line going all the way across the negative x-axis is 180 degrees, yes? I wouldn't write this in, but I just want to draw this in to kind of bring, or just be able to show this to you. What is the difference between 180 and 150? 30, yes? So this angle right here is what we would call a reference angle of 30 degrees. Over here is our 30, yes? So x is square root 3 over 2, y is 1/2. We see for 150, we do have the square root of 3 over 2 and 1/2. But since we're in the negative x, the x value is now negative. Same thing with 135. Well, the difference between 135 and 180 would be a reference angle of 45, which is our 45, but we adjust for the fact that we're in the negative x. And 120 would have a reference angle of 60. That's why they match up. So we're starting to see why this unit circle is kind of nice. Because even though we went to the second quadrant, our values are still the same. Well, when we get down here in quadrant 3, we're going to have negative square root 3 over 2, negative 1/2, negative square root 2 over 2, negative square root 2 over 2, negative 1/2, negative square root 3 over 2. So again, it's very similar to what we just had. It's just now that this is our reference angle of 30, because 210, we're going from 180 to 210, which is 30. 180 to 225 is our 40. And 180 to 240 is our 60. And then 0, negative 1. And our last one, we're going to have 1/2, negative square root 3 over 2. Square root 2 over 2, negative square root 2 over 2. And lastly, square root 3 over 2, negative 1/2. Okay. Now we'll put our positive negatives here. Well, in the bottom one, Positive is tangent. Negative is sine and cosine. And then the last one, cosine is positive. Sine and tangent are negative. Incidentally, our CSC, our cosecant, if sine is positive, cosecant's positive. Sine's negative, cosecant's negative. If cosine is positive, COS is positive, SEC is also positive. If COS is negative, our SEC is also negative. Tangent and cotangent will have the same sign. If tangent's positive, cotangent's value of the same point would be positive. If tangent's negative, cotangent of that same point would be negative as well. They go hand in hand. Questions on this here? And this is the unit circle, and we can use this to evaluate for these here. Yes, sir. Yes. Okay. Evaluate the 6 trigonometric functions. We'll do part A today. We'll do the others tomorrow. So if you didn't fill in the ones on the note sheet, that's fine. That unit circle on the note sheet, because you have it here. The one that you have on paper is more important than that one in the notes. Does that make sense? Yeah. Sine of pi over 6. So we take our unit circle and go to pi over 6. Sine is the y value, and the y value at pi over 6 is 1/2. Cosine of pi over 6 is square root of 3 over 2. Tangent is y over x, the y value over x, or sine over cosine. And I'll write that in here in a minute. So tangent, actually, so sine of an angle is the y value on the unit circle. Cosine of an angle is the x. That's why we have that x-y ordered pair. Tangent of an angle is y value over x. Sine over cosine, the sine's value over cosine's value. CSC is 1 over y. SEC of an angle, 1 over x. And COT is x over y. So tangent in our case would be the y value, or sine's value, 1/2 over square root of 3 over 2. Well, we can't leave it as that, and luckily, one half over square root of 3 over 2. Square root of 3 over 3. CSC, cosecant, 1 over y. So we'd have 1 over 1/2. And you type that in. 1 over 1/2 is just 2. SEC is 1 over x, so 1 over the square root of 3 over 2. 1 over second square root of 3 over 2 is 2 square root of 3 over 3. And cotangent of pi over 6, so it's our square root of 3 over 2 over 1/2. Thank you. Which actually just works out to be the square root of 3. Now we will learn some more properties of these and how to get from one to the other a little bit quicker. But again, most of this we just had to look at our chart and it would give us our values. Because at pi over 6, what's the point? Square root of 3 over 2, yes? What is an ordered pair in the form of? X, comma,
Oh, sorry.
y.
Where did you get the 1/2 before?
Pi over 6? There's again an ordered pair is in the form x, comma, y. Because the x value for this point is square root 3 over 2. The y value is 1/2. So sine is y. The y value is 1/2. Cosine would be x. Tangent is y over x. Cosecant, CSC is 1 over y. 1 over y. Secant, 1 over x. Yeah. Now we'll do more of this tomorrow. We'll stop here for today.